19 minutes.
Okay, let's see all it's got. Okay, 55 says use the remainder theorem for k equals -2 and this function f of x. Okay, it's still a synthetic division problem. F of k equals the remainder is a theorem. It says whenever you get the remainder from synthetic division is the same thing as f of putting in this k value to the function. Bless you.
Thank you.
Now, note that if it says k equals -2, do not change its sign. It already has the correct sign on it. So use it as it is if it says k equals. And then write down all your coefficients, 3, 11, 2, -7, and 62. Notice nothing was skipped on that one, so didn't need a 0. Yeah, because when x4, x3, x2, x1 is there, and then constant. So it's good. Yeah.
Maybe it'll sink in.
So we bring down the first term 3, multiply is -6, add is 5, multiply is -10, add is -8, multiply and add your way through, multiply and add. That last number is all we want here, just the remainder, 44, all we're looking for. So choice B. So it says find f of k, only the remainder.
So wait, you take -8 times it by -2 gets 16. Is that what you're doing here?
Mm-hmm. I'm multiplying here to here to get here, kind of a V. All right, the question on number 56 says factor this function into linear factors given that k is a 0 of f of x. So they've given us something to start us out that k equals -5 should give us a 0. That's what the directions said. So if I do this -5 routine like I did on the last problem, I should see a 0 on the end.
What does that multiplicity mean? Multiplicity.
That means I get to use this twice. -5 should work through the problem again after I do my synthetic division once. I'll repeat it with -5. Okay, so -5, don't change its sign because it's already k equals. Make sure your coefficients are in order with nothing skipped. And remember, we're counting on 0 at the end. So let's see if we do it. Bring down the first term 1, multiply, add, multiply and add your way across. You all watch my arithmetic. I make more mistakes that way than with the algebra. And multiplying is 300, so that looks good. Now what that did for me is it helped me divide the problem. Remember, synthetic division is division, right? It's trying to divide it down and get, like 12 divided by 3 is 4, trying to get it divided down into its factors. It's prime factorization, ideally, in this one. So far we've divided it down and got this from x4 down to x3. This polynomial, if I were to write it out, would be 1x3, 5x squared, and so on. So I've got it partially factored, but not far enough for me to know how to handle it. So I want it to factor again past x3 down to x squared where I feel more comfortable with my factoring. So that's why they told me it was a multiplicity too, because they knew I was going to need help getting it factored down, so I needed another clue. So I did use -5 again. So go through this process, same deal, and I should get 0 again. And so I do. And now that I've factored it twice, this is down to 1x squared, 0x minus 12, and the remainder is 0. So what this means at this point I have, if this were in factored form, I would call it x plus 5. You know how it changes sign when you put the x on it. And I've got it twice, so it'd be x plus 5 twice, squared. Times this, 1x squared. Instead of putting 0x, let's just say minus 12. We don't have to put the 0x in there. f of x equals. So that's in factored form basically because that won't really unfoil, but the directions specify that it wanted linear factors. So it doesn't want anything with x squared on it. It wants it to be x to the first all the way through. So I had to fix this. So to finish solving, what would this be? I can say x squared minus 12. If I was looking for all my zeros, just solving that, I would set this equal to 0. And it would make that 12. And when I square rooted, it would be plus and minus square root of 12. I think that's how they leave the answer.
That's the one that irritated me.
That's irritating, isn't it? I like it like this just fine. This is a good answer. I think we're comfortable seeing this factored down left of this row. But this is not one of the choices. It's close, but not exactly. So, and the deal is, why it couldn't be left like this is it said to write it in linear factors, so I had to break it apart. Instead of being x squared, I had to write it as x times x is x squared, and then plus and minus square root of 12. We're used to only factoring down perfect squares, so the 12 is kind of an oddball, but it's still the same idea. Inner would be positive radical 12x, minus radical 12x would drop out, and last would give me this 12. So it would foil together to be this. And this is the preferred way they've left it in the answer key. Yuck. Sorry. I apologize for my algebra, right? Okay, 57. Okay, this is to find all of the zeros, to find all the solutions. So it's another synthetic division. A lot of problems on just synthetic division in different ways we're expressing it. So it tells me after the semicolon that this is a 0. It doesn't even say k equals. It just says that is a 0. So again, don't change its sign unless it has an x attached to it, like x minus 3 too high. Okay, so we've got the 1 plus I as a 0 in this problem.
And how do you know that's, what do you mean it's a 0?
Let's see, because it's wording it somehow in the directions. It says for the polynomial that 1 0 is given, so it's meaning that that is the given 0. After the polynomial, that should go into it and give you a 0 remainder to help us factor it down. So we take the 1 plus I just as it is and write down our coefficients. And we're counting on a 0 remainder again because our clue said it should be. Now this slows this down a little bit too because you've got this imaginary complex number. It's a real and imaginary put together to make a complex value for us. So there's two pieces of it. So when we multiply it, it multiplies onto both pieces. 1 plus I times 1 is 1 plus I. Then you add the real parts together, that's 4, and bring down your I, 4 plus I. Then we have to multiply this times this, so that really slows me down because I just can't do that off the top of my head, so I have to FOIL that. 2 parts times a 2-parter has to be FOILed. So first, outer, inner, and last. The 1I and the 4I can be combined to be 5I. And the I squared needs to be changed into -1.
So what are we doing? I don't know.
Okay, when the process for synthetic division, you bring down, then multiply, add,
3 days to take this file.
Okay.
multiply. So I'm multiplying, right? So I've got 2 things times 2 things. So that's a FOIL method. So that's why 1 plus I times 4 plus I has to be FOILed together.
Oh, okay, I got you.
And then combine your like terms. So 3 plus 5I. Then we add.
Can we just do the graph?
Sorry again. Then we have to FOIL again. So 1 plus I times -5 plus 5I. FOIL all those terms. 5i and the minus 5i cancel out. 5i squared is minus 5 because I squared changes the sign of that. Negative 5 and negative 5 is negative 10. Oh, that's good because I was supposed to get a 0, so that's good. Okay, so before I erase that, are we okay? Got all that down? I mean, you all can do that. It's just time consuming, right? The foiling method, you do it forever, right? Only thing new there is that I squared is negative 1, so just a little time consuming, but it's what grunt work, right? You just have to do it. But you know how to do it. It's just time consuming.
What's the answer?
Oh, not there yet. Sorry. That's a good question. Okay, now I want to ask you, because I've used 1 plus I, we know that anytime you use a 0, I was just taking a breath, pausing, that you've taken it down from x to the third down 1 degree. So this is 1x squared. A lot of times, once I get it down to x squared, I can factor it on my own, or I can solve it with a quadratic formula. I can take care of it. But this would be hard to do because it's got all this imaginary stuff in it. So there's another way to break it down one more time. And that's that conjugate theorem that said if you use an imaginary 0, that its conjugate has to also work. So that's our clue to keep us going on this and factor it down again. Instead of using 1 plus I, its conjugate, 1 minus I, has to also work. So I should expect to get another 0. This time it'll go a little easier for me though. When I bring down the 1, multiply is 1 minus I. This time when I add, the imaginaries drop out, so it's much better. Multiply, remember the 5 distributes, so 5 and minus 5i. And then all that becomes 0 like we were hoping.
Or if it's easier in the second part.
Yes, much easier. Remember, each time you do synthetic division, you take 1 degree down. So it was x cubed, so this was x squared, so this is x to the first. This means 1x and 5. So if you set that equal to 0, to solve it, it would change its sign. And you all know things attached to x in synthetic division, we change the sign. So that positive 5 changes to a negative 5 because we would need to set that equal to 0 and move the 5 across the line. So now we have our 3 solutions. You know the connection with this is we try to graph these things. So if it's third degree, remember third degree graphs to maybe have 3 solutions and it swirls, one side's up, one side's down. If we don't get to that today, the graphing of that, we're looking for its 3 solutions. So this is a solution, wouldn't see it on a graph, but it is a solution, this is a solution, and then this is a solution. So 3 solutions, third degree. The only real one though is that negative 5. Notice the question was find the others, so it only mentions, this was given, so it only mentions this one and this one as the other solutions.
So it's I minus x.
1 minus,
1 minus I minus 5.
yes.
So wouldn't that just be like an imaginary number?
Which one? This one, yes. But this one's real, so you get 1 real.
Won't be any playoffs for me this week.
Okay, 58. Find all the rational zeros and factor. Now this one just leaves you hanging. It doesn't give you any clues like this will work and try this. Here's a given 0. No clues whatsoever. It just says factor that. So that's beyond what we've been able to factor before. So what we do is we have an educated guess of something that might work, and also you have multiple choice tests. So you might look at those choices and try to work backwards too. But the educated guess for your zeros, what you start synthetic division with, would be factors of this last number, the factors of the